channel Physics Magic by Habib. In the last video, I gave you brief introduction of basic mathematics, and those formulae will help you a lot in coming physics chapters. I hope everyone watched it. If anybody missed it, I am giving the link in the description. You please watch that video. 100% it is the basic one. If you know that, you can solve anything in any lesson. Because if you don't know integration, if you don't know differentiation, if you don't know trigonometric values or functions, you cannot do all the concepts in all lessons. So let us you watch it, and let's go to our today's lesson, work, power, energy, lesson 1. And in this one, let us first discuss about work today. What do you mean by work? In our daily life, work, in many occasions we will use the word work, but I'm not giving all that introduction and all these things here. Let us straight away go to the concept which will help us to do the problems based on the work in a neat examination. First of all, work done is nothing but it's a dot product of force bar and a displacement vector. Force vector and a displacement vector. What is this? Then say for example, here is a body. In this you are applying force in this direction, because of which the body is displacing in this direction and theta is angle between them. Then in that case, you can say that the dot product of these two physical quantities, force vector and displacement vector, we can call as W. That is work. Then work can be written as now F S cos theta, where theta is angle between force vector and a displacement vector. So this is a basic and very important point you have to remember. Depending on the theta, the work value is changing. Maybe F is not changing, S is not changing. Magnitudes you are using same force you are applying, same displacement is there, but depending on the direction of the force, in which direction you are applying the force, that plays a vital role, and based on that one, the value of W changes. Now let us see how it will change, and you remember this will be 100% helping you in your NEET exam. There are 3 cases basically in this one. One is positive work, second one is negative work, third one is zero work. All these 3 depends only on theta. Theta is very danger here. It is making such variations in this one. F is not changing, S is not changing. Only because of theta, the value of W, it may be positive, it may be negative, it may be zero. Let us see what is that. Then first case 1, let us discuss. In this one, then this is the body. Force I am applying like this here. Then because of this, displacement is also in the same direction. Then anybody can say that both are in the same direction. So theta is equal to 0 here without any confusion. Then if you substitute that theta value here, you will be getting W is equal to Fs, because theta is 0, cos 0 is 1. So you got W is equal to Fs. So in this case, because both are in the same direction, you got W is equal to Fs. And this is called maximum work. In this case, work will be maximum. In theory bit also you can expect this one. When the work done will become maximum. When force vector and a displacement vector both in the same direction. I am going like this here. Somebody came and somebody kicked me behind. Then automatically I will go in this direction. His kicking force in this direction, my displacement is also in the same direction. When both happen, you know well here, maximum work will be done on me. And what I will do, you know well here, I will be falling down. So this is the first case. In this case, work will be stated as positive and maximum. Then case 2, let us see. In this case, body will be same, force will be same, but let us suppose because of the application of the force, instead of going in this direction, let us suppose it is coming like that. I will give some example also to you. I will give example. In this case, what is happening? You can say here theta is equal to 180 degree. And in this case, if you substitute 180 here, cos 180 you know well minus 1. If you substitute that here, it will become minus Fs. How dangerous it is. Magnitude of the work is same, but it is minus. Means it is the minimum work. It is the maximum work. Depending on what? Not on F. Not on S. It depends only on the angle. So theta 0, maximum. Theta 180, minimum. Then what happens the case 3? But before going to case 3, let me explain about these two. For example, here is a body and you are lifting the body like this. So you are called an external agent. You are lifting the body like this. Say this is one duster. I am lifting this like this. So I am lifting like this. So it is happening like this. So you are applying the force like this. So displacement is also happening in this direction because it is going up. So maximum work will be done because theta 0 here. Say instead of this external agency force, I am applying the force. But when I am applying the force on the body, earth will not keep quiet. You know well, gravitational pull will be on the body and that gravitational pull will be in the downward direction. Then that gravitational pull, if you take here, say let us suppose it is Fg. Gravitational pull is in the downward direction, but the displacement is happening in the upward direction. But if you consider here force direction and the displacement direction are opposite, you can take, in this case, work will be minimum. Similarly, you can take another example, frictional concept, friction. So any such examples you can take when the situation comes, I'll explain you. Then the case 3, 0 work. What is happening here? Say for example, here is a body. You are applying the force like this, but the displacement is happening exactly perpendicular. Say for example, F bar and S bar. So here is angle between them is 90 degree. So in that case, what happens, you know well here, cos 90 if you substitute here, you will be getting here 0. What do you mean by this? Force is there clearly. Displacement is there clearly. But because of 90 degrees angle between those two, the work is said to be done 0. The best example for this one is a lifter. For example, a weight lifter. He is lifting his weight like this. The moment when he is applying the force and displacement is happening in the weight, work is said to be done. But he is holding like this. He is holding like this. Then what is happening here, you can see here. If he holds, then what will happen? Automatically no work is said to be done. And here, if best example, one more I will give you. A porter is holding something on his head and he is walking like this. Then you know well here, the weight is acting in the downward direction, but he is walking like this. Displacement is in this direction. So it is acting in the downward direction. Then both are at 90 degree. Then work done will be 0. Similarly, lawn roller example you can take. If you push down, but it will go in this direction. So any examples you can take anything, depends on you. But one thing I want to tell you here, even though force is there, displacement is there, depending on the angle, then the work done will change. So these are the 3 important cases we have to remember. And moreover, this is a very, very important formula when 2 vectors are given. So how to find out the work, and these are different related formula. I hope you understood very clearly, and this will help you a lot. Now, if we go to another very important case in this, meanwhile anyhow, we are discussing work is a scalar quantity, because you know well the dot product of 2 vectors is a scalar, and work will be measured in joule, joule, you know well. And another very, very important concept I am taking here. Let us suppose a particle is here. This is at a position, say R1. R1. So now because of the application of the force, let us suppose its position is changed to R2. Say this is R1 bar, this is R2 bar. Originally this is the initial position. Now because of the application of the force, it moved to this is the final position. Say this is x1 and this is x2. Then force is applied like this. So this is R1 bar and R2 bar. In that case, how to find the force? This is another very important concept because previous NEET examinations on this concept only we got 2 times questions. Immediately after this concept, I am going to refer those 2 questions also. Now, let us see here. Work done is equal to, as per our formula which we have learned, F bar dot S bar. Because force is clear and displacement is also, you can say here. So this is position x1, x2, 2 points I considered. But its position vector of the first one is R1 bar and the second one is R2 bar. So the displacement I can take here as F bar dot R2 bar minus R1 bar. Means R1, position vector of the first point he will give you. Position vector of the second point also he will give you. Then he will ask how much work is done in displacing the particle from here to here. In that case, you have to use this kind of formula. Then R1 bar will be given, R2 bar will be given, and by using this R1 and R2, we can easily do that. So what problems came on this? Then we are going to do those 2 problems now. Let us see. So the concept what I explained, don't take it easy. Based on that one, 2 years, recent years, 2013, 2016, 2 years questions appeared on this concept. Just imagine how important concept I explained. Then definitely if you are aware of that, surely you will get the marks. Anyhow, here very simple, looking very lengthy question, but very simple here. Then force bar is given 3I plus J Newton. Then I told you initial position, as I told just now, this is one position, this is another position. Then the first position he gave as 2I plus K meter, and the second position he gave as 4I plus 3J minus K meter. Like this only. But I am not going to take all these also. Very simple. I am going to explain you. R1 bar is equal to 2I plus K. This is the first position. Now the second position, they only gave 4I plus 3J minus K. So this is the first position. Then this is the second position. Then how much work is done by the force? You know where already I told you. W is equal to F bar dot S bar, where S bar is nothing but what here? S bar is nothing but what? R2 bar minus R1 bar. This is also explained there in the concept. Now R2 bar minus R1 bar. I am not at all interested to write in detail because you can easily do 4I minus 2I. It will become now 2I. Then plus 3J, here 0J. J term is not there. So 3J minus 0, then it will become plus 3J. Then minus K, minus of plus K. Because here is minus. So here is minus of this minus plus K here. Then you will be getting minus K means you will be getting minus 2K cap. Very simple, because to explain you I am writing like this. Otherwise it will take less than 1 minute of time to solve the question. Then F bar is given this one and S bar we got this. Therefore work done is equal to F bar dot S bar. F bar means 3I plus J. So the I component of this one is 3 and here is 2. Then you know well here 3 2s are 6. Because the dot product already you know well what you have to do. 3 into 2, whatever the I value here, just simply multiply. There you will be getting plus 1 here and here 3. 1 into 3, then it is 3. Then k is not there, so 0 here. 0 into something becomes 0. So it is equal to 9 joule. Simple. This is how we have to do. Then you know well here the dot product, already explained you how to do the dot product. So 3 into 2, 6. Here j is 1, here j is 3. 1 into 3 is 3. So k term is 0 here. 0 into this one 0. Then if you add this, you got 9 joule. How simple it is. It is worth of 4 marks. Then if you go to this question for practice purpose, I gave you. Very easy to do. Same force vector is given. R1 bar given. R2 bar given. Then R2 minus R1 you find out. You will be getting displacement. Then once the displacement if you get F bar dot S bar, compulsory you practice it, you will be getting answer 5 joule. So this is how that concept helped us. Then we will go to the next concept. So actually that is one important problem we have done. Like this, applications very important. Direct formula, if I say, I can give you different formula, different problems. Okay, these problems you practice like that, I can say. But my intention is not that one. Concept is very important. So far what you have learned is very simple. But now some more complication I am going to add here. There are 3 kinds of questions we will get here. In order to do that, first of all, we should know some basic information regarding energy. You are familiar, potential energy, kinetic energy, work energy theorem. Work energy theorem in detail we will discuss in near future in my next videos. But basically some basic fundamental questions are also asking to find out the work done. But in order to do those, we have to take the help of work energy theorem. You know well here what this work energy theorem states. Work energy theorem. If you do this one, then you know well here the total work done is equal to change in kinetic energy. The total work done is equal to change in kinetic energy, means final kinetic energy minus initial kinetic energy. Then in order to find out, here you are finding work only. You are finding work only. But you have to do like this. But based on this one, there are 3 kinds of questions will be asked. The question number one form is like this. When position, time, equation is given. Then when velocity, time, equation is given, or when velocity, position, equation is given. So there are 3 different kinds of equations you will be getting, and definitely I will explain you in your previous NEET examinations also some questions came based on this one. But this is concept. If you understand the concept, any question you can do. Definitely other than this you won't get. So there are 3 kinds of equations we will be getting, and with the help of that he will ask us find out the work. So first one is the position time equation is given. Like say for example, then x is equal to then function of t. Then velocity time equation is given. Velocity is equal to function of t. Then velocity position is given. Velocity is equal to function of position. Very clearly you can understand here. This is somewhat higher level. You please don't worry and don't feel that physics is such a subject which if you learn it with interest, you will get everything. But if you feel, wow, equations are coming, once again functions are coming, Abhibs are also explaining the same thing. If you feel like this, you will never learn the physics. I'm going to explain some problems on this. You will only see, after those problems, you will say that how easy these are all. 100% be confident, you will get it. So, there are 3 kinds you will be getting here. One is, if the position is given as a function of time, then how to do. Then this, how to do. Then this, velocity is function of position, then how. But in all these cases, we will take the help of this one only. Then how? We will discuss in detail. Now first, if this is given, when position time is given, let us say first that one. Then case 1, I will explain you with examples. Case 1, just I told you, position time equation is given. Say for example, x is equal to function of t. Remember students, definitely you will be getting like this only equation. When you get this, simply what you do is differentiate this with respect to time. Then you will be getting velocity. So whatever the given function, you differentiate that with respect to time. Simply you will get velocity. Once velocity comes, you know well here just we wrote the kinetic work energy theorem. Then find out initial velocity. Find initial and final velocities. Then once initial final velocity comes, you know well here W is equal to half m into V final square minus V initial square. If you use this, you will be getting the work done. So surely this kind of equation you will get. When this equation comes, you learn the concept, then you will never forget this. One example also I am going to explain on this. Then the second one is, I hope you noted down this, and second one, case 2. Case 2 I will write. Case 2. Velocity time equation is given. Then velocity is equal to function of time. There is nothing to do. Some students here, what they will do is, once again they will integrate this. They will find out displacement. With the help of displacement, they will find out work. No need of all this. Very simple. When velocity is given, reference points will give. Then you find out initial velocity. You find out. Then final velocity you find out. After that, once again, same formula. V final square minus V initial square. This is how simple. Looking equation and all these, but you just check first whether in the given question x is function of time, then immediately the previous procedure what I told. If velocity is function of time, then simply use this one. Similarly, the case 3 is also there. I will explain case 3 also, and after that we will do some numericals on that. Then you will be getting a clear idea. Case 3. Then V is equal to f of x. So velocity is function of position. Velocity position equation, this is called. 3 are different. Except these 3, 100% you will never expect, you will never get any other kind of question. So velocity is function of position if it is given. Then simply here also, Vi is equal to how much you find out? V final is equal to how much you find out? No need to do any differentiation, no need to do any integration. Simply final velocity, initial velocity you find out. Once again use the formula half m into V final square minus V initial square. This is how we can find out work done in all the 3 cases. Okay, then we will do some problems based on this one, how it will be asked. So to give you more clarity, let us suppose case 1 I am taking here. Position time equation is given. Then how to do this? Then a particle of mass 2 kg moving along x-axis for 2 seconds according to equation x is equal to this one. Then 99% of the students, when the equation is given, they will think that okay, these questions we cannot do. Simply if f bar is given, s bar is given, I will do. But equation means it is not possible for me, like that will think. But how simple it is. You just understand, just only I gave you the concept. Position time is given. What? We know the concept. Simply differentiate this. You will get velocity. Then use work done. Then see how I am doing. Now, mass is given 2 kg. Let us use that later. Now, x is given, this is solution, x is given t cube by 3. Thereafter, if you differentiate these ones, dx by dt is equal to, you are familiar, t cube is nothing but 3t square, because power we have to write first t into 3 minus 1, that is 3t square by 3. Then we got here 3 gets cancelled, but dx by dt is nothing but v. Therefore, v is equal to t square. We got velocity. Then you know that it is for 2 seconds that force is applied. Now, initial, v initial means at t is equal to beginning, in the beginning. T is equal to 0. T is equal to 0 means v initial will be 0. Then after t is equal to 2 seconds, v final is equal to, so t is equal to what here? At t is equal to 2 seconds, if we apply here, 2 square is nothing but 4. Here it is t is equal to 0, here t is equal to 2. Then you got v final and v initial. Then simple formula what I said, w is equal to half m into v final square minus v initial square. It is nothing but half, m is how much? 2 kg. Then v final is 4. Then 4 square minus 0. There these two gets cancelled. Simply you will be getting here 16 joule, because 0 no need to consider. This is how simple it is. To explaining purpose I am writing this much, but in one step you will get the answer. So it is looking like equation, but very simple. So when position time is given, you have to do like this. I hope you understood this case. Then, so the first one is only difficult, but the second case and third case are very easy. Second case is direct only. Velocity time will be given directly at a different timings. The different velocities will be given. You have to find out the initial velocity. You have to find out final velocity. Thereafter, you can easily do that. The third one, that's why I'm explaining, velocity position equation is given. Then how to do. So one question is given like that. Particle of mass m moving along x-axis according to equation v is equal to a root x. From x is equal to 0 to x is equal to d, it is displaced. Then find the work done. Then in this case, I told you velocity is the position of, or velocity is the function of position. Means velocity position equation is given. In this case, no need to do anything here. I told you already. V initial you find out. V initial means that x is equal to 0. If you substitute that, happily you will get 0. Then you go to the second one. V final is equal to a into under root of d, where in place of x just we substituted d. Thereafter we got initial and final means you know well here. W is equal to half m into v final square minus v initial square. Thereafter half m into v initial is 0, v final is a square into d minus 0. A square of this one will become square and root gets cancelled, d only will be left. So a square d here minus vi is 0. Therefore w is equal to half m a square d over. How simple. So when equations are given, we may be feeling that it is tough. Nothing is there. Simple. So there are three kinds of equation. The first one already I told you, position time. How, what we have to do I told you already. We have to do differentiate, find out velocity, then initial final velocities we have to find, then we have to use the formula of work energy theorem. Then the second one is velocity time is given. Nothing to do. Directly find out initial and final velocities, find out the work done. And the third case is velocity position is given. Then you have to do like this. This is one example for that. So I hope you understood all these three different cases. How to find out the work done when a constant force is given. So surely I hope this will help you a lot. And in the next class, tomorrow, we are going to discuss about how to find the work when a variable force is given and how many cases are there in that. Also I am going to tell you. You observe my teaching is not simple, but I am giving conceptual information to you. If you are strong in this, 100% success is yours. Good luck.